Last presentation, which will be given by Xuanyi Shi, who is the product manager at Astronergy, and she will talk about the advantage of Astronergy's TOPCon products in distributed PV applications. The floor is yours.
Thank you, Michael. Okay. Thank you, Michael. Let me share the presentation. It's my great pleasure to give a presentation in this conference. I think after this presentation, can you do that for me, please? Move on. Okay, so today's topic is the advantage of Astro N in distributed PV application, and the Astro N is the TOPCon module manufactured by Astronergy. I have 4 sections in today's presentation, and in the first section, we briefly talk about the market trend, and then in the second section, I will introduce Astronergy's TOPCon product. And then thirdly is we evaluate the values to downstream stakeholders, including the installers and the end user. And then in the end, it's Astronergy's up-to-date capacity layout. So here is the database from PV Info link. You can see there is a promising increasing trend of the market demand. And in this year, the demand will reach to 350 to 400 gigawatt. So which allows the module manufacturers to increase their manufacturing capacity. And then the right-hand side graph shows the PV market demand of various wafer format. So in last few years, the wafer size is getting bigger and bigger, and the logic behind it is the reduction in balance of system cost. And however, by last year, the wafer size stopped at 182 and 210 because so after a certain amount of increase, the system cost reduction is getting smaller. So and we have to make a trade-off between the system cost reduction and the challenges that very large wafer size brings us. For example, the mechanical load and the difficulty to make a uniform deposition. So currently 182 millimeter wafer dominates the market. Next slide, please. Thank you. And for the cell manufacturing capacity, so in last year is a turning point for technology transformation, since PERC is very close to its technology efficiency limitation. So the manufacturers to start to invest in new technologies, including TOPCon, XJT, and the XVC. And among these emerging technologies, TOPCon develops most rapidly, and by the end of this year, it will reach the same capacity level as PERC. Saying about the distributed solar, a very common application would be the rooftop PV system, and it has a lot of special features compared with ground-mounted power plant. So the system size of rooftop PV is very often limited by constrained areas. So using more efficient modules will directly boost up the system size, because more high efficiency means you can achieve a higher system, you can have more power with the same area. And then secondly, there is often small gap between the panel and the roof, and the poor air circulation would result in poor heat dissipation. So the modules operating on rooftop generally has a higher temperature compared with those working in ground-mounted power plant. So a good temperature coefficient would be a very useful parameter in this application because it allows panels to generate more electricity at high temperatures. And in addition, for panels with high current output, you have to be careful about the cable ampacity because the ampacity of cables decreases under high temperature. And for rooftop PV, it has relatively higher balance of system cost, especially in the United States and Europe. And then in the second part, we talk about the Astronergy's N-type product. At the current stage, we have 4 panels format for residential rooftop. So they are all made of 182 millimeter TOPCon cells. So the smallest one, all of them have 6 strings of cells in the module. So they have the same short side length of 1134 millimeter. And what different is their long side length. And the smallest module has a long side length of 1722 millimeter with weight of 20.8 kilogram for dual glass design and 21.3 kilogram for glass backsheet design. And this module format is designed for residential rooftop with limitation to the panel dimension and the panel weight. And then the next dimension has a long side length of 1903 millimeter. So this one can be either used for residential or commercial and industrial application. And then the third one has a long side length of 2278 millimeter. So this is designed for commercial and industrial application. And then the largest one has long side length of 2465. So this is designed for customers who need high power rating. So you can see we have various dimensions to meet the needs from various customers. And all of these modules adopt similar module technologies. We use phosphorus doped large format silicon wafer, and it will be made into high efficiency TOPCon cells with efficiency more than 25.4%. We use multi-bus bar and half-cut design to improve the tolerance to shading and the cracking. And we use non-destructive coating and improved frame design to enhance the mechanical property. We use improved material to give aesthetical appearance. For example, we use full black design. As we mentioned, we have 3 panel format for commercial and industrial application. So they have a format of 18278, 18272, and 18260. So 78, 72, and 60 is actually the quantity of the cell in that panel. So you can see they have different dimensions and different power rating, and you can choose the product that mostly suit your fit into your system. And then for residential PV application, we have 18254 format panel, and we make it with various external features. The left-hand side product is the ordinary design with white frame and white bus bars. And then in the middle is full black design, black frame and black bus bars. And then the right-hand side shows a double glass transparent design. So transparent here means the gap between the cells and the gap between the cell and the frame are transparent, which allows sunshine to come through. So it's very is suitable for carport or agriculture application. So all the modules we mentioned are based on TOPCon technology. So I'd like to give a brief explanation why TOPCon can achieve high efficiency. So TOPCon is essentially a structure on the rear of the cell. So it is consist of a tunneling oxide layer and a N+ poly layer. So N+ poly layer is actually a heavily doped phosphorus doped polysilicon layer, which can cause energy band bending to achieve carrier selectivity. And in another word, so when free electron moves from the bulk silicon to the electrode, the TOPCon structure can give it a small energy band gap. So the electrons can be easily passed through the TOPCon structure and being collected by the electrode. And in contrast, when the hole arrives, the TOPCon structure will give large energy band gap, which repels the hole to the bulk. So when the free electron and the free hole does not meet, the recombination can be reduced. And additionally, this structure also isolates the electrode from the bulk, and so it can also reduce the contact recombination, and that's the reason for TOPCon to give higher efficiency. And then at the module level, Astro N has several advantages. So it has high power and high efficiency due to the adoption of more efficient TOPCon cells, and the power rating is about 15 to 30 watts higher than PERC, depending on the format you choose. It has high reliability. The first year degradation is smaller than 1%, and the annual degradation is smaller than 0.4%. And it provides high energy yield due to its better temperature coefficient, high bifaciality, and the better low light performance. And then for the module cost, at the current stage, the cost of TOPCon is still slightly higher than that of PERC. But since last year, we have been made a lot of reduction in the TOPCon's cost, and we aim to reach the same cost as PERC by further increasing its efficiency and reducing its manufacturing cost. And we also have a new product called Astro N7 and N7s. So what different is we use 182 rectangular wafer. So it's no longer 182 times 182. It's 182 times 191+ millimeter. And it has the larger format module has a dimension of 1134 times 2384, and with maximum power rating up to 615 watts. And then the smaller one has a dimension of 1134 times 1800 with a maximum power rating of 450 watts. And the volume production will be started in the third quarter this year. And then in the third section, we evaluate the values of Astro N to the downstream stakeholders. Let's put this into a scenario. Let's say we have a residential house with constrained rooftop area, which only accommodates 20 panels, and the installer and the house owner need to make selections of using either traditional PERC module or Astro N TOPCon module. Then we make a very simple calculation to evaluate the profit to installers. Let's say we have PERC and Astro N. The panel power of Astro N is 20 watts higher than PERC, and they have the same dimension. And we assume the panel price for Astro N is 0.5 euro cents per watt higher than PERC. So it's a little bit more expensive. And we have 20 panels on the rooftop. And the labor cost and the balance of system cost in order to make such system is 2,200 and 4,400 respectively. That's just assumption to the cost. It's not actual one. And then the system And then the installer can sell this system to customers with a price of 1.1 euro per watt. And then let's make a calculation on the profit of installers with the system using TOPCon and using Astro N. So we mentioned the Astro N is more efficient, so the system size can be increased by 0.4 kilowatt. And then the revenue equals to the system price multiplied by system size. Since the system size is increased, the revenue is also increased. And the increase is 440 euro. And then the total cost equals the labor cost plus balance of system cost plus panel cost. And the labor cost and balance of system cost do not change for the two panels. The panel cost is increased by 145. So that's the total cost is also increased by 145. And then the profit equals the revenue minus total cost. And we found out that using TOPCon, the system profit can be increased by 295. So the idea is that we by using Astro N, we increase the system size, and the revenue is directly related to is directly proportional to the system size, but the cost is partially related to the system size. That's why Astro N can make more profit for installers. And then from the perspective of end user, we continue with the same scenario. The system size is increased by 0.4 kilowatt for Astro N. And the end user also need to pay an extra of $440 euros for Astro N system. And on the other hand, we mentioned that TOPCon can generate has a higher energy yield, and this means with the same system size, TOPCon can generate more electricity. And in this case, for each kilowatt of the system, TOPCon can generate an extra of 30 kilowatt hour electricity. And then on the system level, we also need to take into account the system size increase. TOPCon can generate an extra of 926.8 kilowatt hour electricity in the first year. And then let's look at the electricity charge. So we assume the household electricity charge is 0.22 euro per kilowatt hour, and this electricity charge has already been is a rate per kilowatt hour. So we already subtracted the fixed part from the total electricity charge. And then the feed-in tariff equal to 0.086 euro per kilowatt hour. And this system we assume is of storage, so the self-consumption is 30%. Then we can simply calculate the weighted average electricity rate to be 0.1262 euro per kilowatt hour. And we multiply this number with the first year energy generation to get the first year income. And Astro N can increase the first income by 116.96. And if we compare this increase in income with the increase in initial investment, we found out that after 3 to 4 years, the increased initial investment can be paid back. And then on the right-hand side is a cumulative cash flow. So you can see at year 0, the green bar is the Astro N and the white bar is PUC. And at the beginning, so the initial investment for Astro N is a little bit higher, but at the 4th year, the cumulative cash flow becomes the same. And then after that, Astro N would have a better cash flow due to the higher energy yield. So the end user can also be benefited from Astro N due to its higher energy yield. And then in the last section, we give Astronergy's up-to-date capacity layout. By the end of 2022, the manufacturing capacity is 20 gigawatt for modules. And for this year, by the end of this year, the total capacity for modules will reach 48 gigawatt. So it's almost 2.5 times of last year's manufacturing capacity. And the most of the newly increased capacity is N-type. We have 34 gigawatt of capacity for N-type cell and N-type module. And we have more than 70% of the module capacity belong to N-type. And then by end of 2025, we have the ambition to increase the manufacturing capacity to 90 gigawatts. And this slide is the manufacturing sites. Currently, we have 5 factories are already in production. And in this year, we will have another 5 factories in construction, and all of them can be finished by the end of this year. Then all of the 10 factories will start mass production by the end of this year. Thank you for your time and listening. You're welcome to ask questions.
Thanks, Zoe. So as you're expanding into TOPCon, how do you see actually the demand for TOPCon versus PERC, and also in different regions? So as I hear in Europe here at the moment, everyone wants TOPCon. So it's
yeah, so actually it really depends on the module price, I think. So for Europe, United States, and they want, and Australia, they want TOPCon, they want new technologies because they think it provide better levelized cost of energy. But still there are regions they want a smaller initial investment. And for these regions, they want lower module cost.
Okay. Interesting. Any further questions? Okay, I think that's it. Thanks so much for this
Thank you.
great overview.